So stupid.
Now, my friends, I have one more definition to do, but for this definition, I actually would like to do 3 different triangles. But if you need more time to write this one down, I can wait. So lower your hand when you are done writing.
Get it.
All right. So the next definition is about the altitude of a triangle.
La 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 la. Oh my god.
So an altitude of a triangle is a perpendicular segment. And remember that perpendicular means it meets at a right angle. A perpendicular segment from a vertex to the opposite side, or to a line containing the opposite side. So I'm actually going to make 3 triangles to illustrate this. I'm going to do an acute triangle. I'm going to do a right triangle. And I'm going to do an obtuse triangle. Zoom, zoom. And again, I'm not constructing this, right? I'm making a drawing and sort of approximating as best I can what this looks like. So here is an altitude of an acute triangle. Again, it goes from the vertex to the opposite side, and it meets it perpendicularly. Notice that this is not necessarily bisecting my other side, and the altitude is inside the triangle. This is also known as the height of the triangle. So for those of you who maybe remember the area formula for the area of a triangle, 1/2 base times height, this would be the base of the triangle, and the length of this altitude would be the height of the triangle. Now for a right triangle, where we have a right angle already present, then the altitude is one of the sides of the triangle. So this would be considered an altitude of the triangle, as well as the second side is also an altitude of the triangle. So this means an altitude can be one of the sides of the triangle. And finally, and this is my last shape, I want to talk about an obtuse triangle, where one of the angle measures is obtuse. And in this scenario is why we have this or spot up here, or to a line containing the opposite side. So if I consider this vertex up here, in order to meet the opposite side perpendicularly, I need to extend one of the sides of my triangle. And so I do this with sort of like a dashed line. And then from this vertex here to draw perpendicular line extension. So in this case, the altitude is outside.
Are you supposed to press it? Poppy, are you supposed to press it?
Of the triangle. And of course, because there's 3 vertices, there are 3 altitudes for every single triangle. And they also have a special property that we will discover in class on Thursday. That is the end of my lesson, my friends. I just want to point out one other thing, and that is that in Schoology, there is some videos for you to watch if you so choose, that are related to the classwork that we did last week. And those videos would be about the angle bisectors. So looking in our Schoology page, under resources for the unit constructions and proof, there are some videos here about
I'm ready, Sarah.
constructing angle bisectors.
Can we just get on with the lesson, please? Oh, wait, you can hear me? Cool.
And I was just trying to get to my other video to maybe if I unpin this.
I'm so sorry, Sarah. I'm sorry, Sarah.
Yeah. All right, my friends, that is it for today. It is 10:55, so you have a 5-minute break before going to your next class. Send me emails if you want to meet with me this afternoon. I'm happy to meet with you either by camera or by Google Meet or even just by email. That's it. Goodbye.
Decent. Anyway, I'll turn this class to,